Welcome, everyone. Today is Wednesday, the 29th of November, 2023, and this is the Cluster API Karpenter Feature Group meeting. We are a sub-project of Cluster API, which is a sub-project of Kubernetes SIGs, and as such, we follow the Kubernetes SIGs guidance for meetings, which basically means please treat everyone as you would expect to be treated, and if you'd like to talk, please raise your hand and I'll call on you. So with that out of the way, yeah, I had a couple items I tossed on the agenda that I'd like to talk about, and I invite anyone else to add stuff to the agenda as well, if there's topics you'd like to get into. So the first one, and this one is pretty easy, so we can get it out of the way right away here. Should we cancel the meeting on the 27th of December? I will not be able to make it because our office is closed that day, but I didn't know if there's any objections or if people would like to meet then. Looks like thumbs up. Cool. All right. All right, so that's easy. So now the next topic. I've been like really curious about what Ellis talked about in the last meeting, which was basically kind of pushing back on the initial assumptions that I had been proposing about where do we integrate? How will we integrate? And could we integrate at the controller level in Cluster API so that Karpenter and Cluster API kind of look more like peers rather than some sort of like parent-child type relationship? And I was talking to some colleagues internally at Red Hat who are also working on Cluster API, and they thought that was a really interesting idea. So I've been exploring that. I don't really feel comfortable enough yet with Karpenter's internals to really, toss a lot of this stuff around. But one thing I was curious about, I was looking at the node class that gets passed in to the providers when, as I guess I'm still trying to understand how this CRD works, but like it seems like every provider has a node class of its own that kind of wraps node creation. And so I'm wondering, is it appropriate to think about the node class in a way where we, for Cluster API, would that be something where we would like wrap an infrastructure machine object or something, so that I know there's like an interaction between, the way that you you set up the node provisioners and the node classes, and it looks like the node class can be tweaked a little bit, but I'm not quite sure if that is accurate or not. And I don't know if anybody here has kind of looked at it at this layer or not, or if anybody has comments on that. All right, I'm guessing that there are no comments on that. This is what I've been looking at though, and I'm really curious to see like, and I don't quite understand Karpenter well enough, yet, and maybe some of y'all, have a better notion of this. But like when Karpenter wants to scale something, how would we integrate with the Cluster API controllers in such a way that they could like interpret that? Like, what CRD are we looking for on the Cluster API side? Or is this all handled through the interface? Because studying the cloud interface for Karpenter, I can see where it wants to say make a new machine, it wants to hand in kind of like what it wants to be made and everything. But I haven't yet got to the CRDs that kind of handle this. Does anybody else have kind of like insight on this side of things?
Yes, I can comment a little bit. So the way that we're handling this today, so you're right, like the cloud provider interface is providing some of the like internal nuts and bolts on like how the cloud provider itself actually is responsible for like launching something. If you looked at the cloud provider interface, I think you probably saw the node claim being used on there. And so not to confuse the two things, but node claim is basically the I want a cloud provider machine construct inside of Karpenter. So Karpenter will do the math on the pod scheduling to possibilities, so that those possibilities are received from the instance types call, which is part of the cloud provider interface. And then it uses those possibilities to generate what it thinks are the best options for the pods that it needs to schedule, and then generates node claims off of that. And so those node claims are then reconciled through the node claim lifecycle controller, and that will generate calls out to the cloud provider create. And so then from that side, like the node class itself as a custom resource is kind of, I'm kind of opposite you, Michael, where it's like, I don't have as much familiarity with Cappy, but I have like deep familiarity with Karpenter. But the node class is basically the representation of all the infrastructure specific settings. So we've kind of grouped out our node pool to be the common layer across all cloud providers, and then said that the node class is like the specific bootstrap settings for that specific cloud provider. When it comes to things like specifying like security groups or subnets or user data, or whatever you want to call it within the different cloud providers that exist today.
Okay, please.
Yeah, cool. Thanks for letting me barge in. I think you've had a couple of these meetings, so I apologize if some of these questions have already been posed and answered, but I'm unfamiliar in Cappy. Is there a way to create something like an orphan machine? So just a machine with no machine deployment on top of it, or in the case of machine pool, a machine pool? Because the way that I'm thinking through how this would work is it would have to be, it's not that there's going to be a one-to-one mapping between a node claim and a Cappy CRD. It's going to be more like a set of CRDs, because we have to think of Karpenter as a full end-to-end provisioner. It's not like cluster autoscaler where it's simply like, you're going to implement some sort of thin interface that allows me to increment or decrement a replica count of a known thing. In this case, we're going to want to have to provision the whole thing. Like the obvious reason for that kind of architectural requirement is maybe too strong of a word, but the obvious stuff that comes to mind is the fact that Karpenter is designed to create at a given time an appropriately sized, shaped node that fulfills the requirements in the most efficient way. And efficiency can be defined as a function of cost, as a function of various eco attributes, as a function of, But the point is that like when Karpenter's creating a node, it's using real-time environmental criteria to decide what to create. And if you want to do Karpenter right, you want that decision to be informed by a full sort of suite of possible infrastructure to choose from, and it can make its correct sort of real-time decision. So how I imagine that could work in a Cappy world is that it's still hard for me to wrap how we could do a Cappy provider and not very particular providers, but maybe it is possible. But you do that sort of environmental introspection, and then at the end, in order to do the plumbing into Cappy, you have a set of sort of necessary CRDs that can create that particular machine. I mean, maybe Karpenter is going to create n number of machines, but really, I think the easiest way for me to think about it as a human with a tiny brain is that each of those, in each of those sets, there's going to be a very particular opinionated like machine. And so I'm just imagining that a set of CRDs, like an AWS machine, a machine, all the necessary things that are going to go together to create this new infrastructure in a Cappy environment are going to be in play here. So it's not just going to be like a Cappy machine. It's going to be, Karpenter is going to spit out the set of necessary cluster API CRDs that are going to build that AWS machine, that single AWS machine that's running particular 32 core profile, whatever. And then the corresponding Cappy machine. But I don't think can't just create an AWS machine without creating the Cappy machine. And so does all this make sense?
Yeah.
Has this been covered?
Yeah. It hasn't been covered per se. Like we've been talking about a lot of these concepts. And I tend to agree with you to some extent, right? Like, yes, like it can't work the same way that the CAS does, right? It can't just increment a replica and then that's the end of the day, right? But like, I think there are a couple different ways to look at this, right? And this is why Ellis's suggestion from last week or last meeting, I thought was really keen and caused me to kind of look at different things, which is like, okay, could we make is there a way that we could make the cluster API side of this? We could generate a contract that providers could kind of, provide, and then that would give them a way to like see what Karpenter wants to do, and then be able to satisfy what Karpenter wants to do. So that's one thing. Like, could we actually like create some sort of common framework that every provider could create this if they wanted to do kind of CAPI interactions? And then another way I've been looking at this is also like, kind of like, could we do it in a way that's similar to the cluster autoscaler? Because you're right in that this isn't just a matter of incrementing or decrementing a replica count. But that said, we have very good conditions and statuses so that we could increment the replica count and then follow the cycle of that machine that's created to bring it back and give it to the cluster or whatever. But that's pasting over all these details that I think you're getting into, Jack, which is like every provider is going to have a different kind of infrastructure, template or whatever, right? They're going to have different parameters that go to that infrastructure to make those things. And I think in the Karpenter world, the way that I'm seeing that is that, yeah, every provider creates a node class, and that node class has all those kind of details. And then when Karpenter looks at kind of the provisioning requirements that you have in combination with the node class that it has, and it can kind of come up with something that says, I want one of these with these options on it, right? And I think that interaction is going to be really difficult for us because we have not historically in Cluster API had a good way to surface details back out through like CRD objects and whatnot, right? This is all handled at the provider level. So like, I'm not even sure that we could make like a genericized version of this. I want to be optimistic about it, but I think maybe it might make more sense for us to kind of get into this of like, what does Karpenter create? And then what controllers could we add to Cluster API that could react to Karpenter? So I guess, does that make sense back to you, Jay?
Yes, it does sort of. I mean, what I'm hearing you say is that we would have a common interface that the cloud providers would opt into if they wanted to be sort of API Karpenter powered. So this new common interface would be something that like Karpenter could use to introspect. Okay, this is my compute requirement, or this is basically Karpenter has its like abstraction and its set of requirements, and it calls into this new CAPI interface, which returns at runtime the set of environmental specific things that Karpenter can then use to make its provisioning decisions. So if you're running on AWS, this CAPI specific interface would the Kappa providers would implement would execute an implementation of that new CAPI Karpenter interface to return. All right, so you need 32 compute. Here's a bunch of options back. Like that kind of makes sense to me. I don't know if that's what we're talking about. That kind of makes sense to me. I don't know how. I don't know. It's not clear to me why we need to implement anything new in terms of the singleton, the set of CRDs that are required to like implement a singleton machine. So you've got your CAPI machine and then your underlying infra machine. As long as we can do that without a machine deployment in CAPI, and that's idiomatic and fine, then I think we have those necessary CRDs already exist. Yeah, I'm kind of trailing off here.
Yeah, no, and there's a lot of details to work out here still. And I think like where I can hear you kind of come into the head here is exactly, in my opinion, where the details are, right? Because every provider's got a different kind of, set of parameters they want to expose and different things they want to do. And Karpenter needs to know about those so that it can make the decisions that it needs to make, right? So the way I look at it is there's kind of like two big interface pieces that need to happen between Karpenter and Cluster API, right? Like a Cluster API provider needs to be able to tell Karpenter what instance types or shapes are available, right? So it needs to be able to provide that and say, this is the palette that you can use to paint with, right? And then there also needs to be an interface on our side, basically, for us to interpret when Karpenter wants to make a, like a node claim, that we can interpret that properly and create the kind of node that it's looking for. And so, yeah, like the details about machine deployments and machine sets, and do we want those to be working in there, or could we just make orphan machines and people would be okay with that? I think these are good questions, and I want to kind of capture that one. Would the community be okay with orphan machines? Because that does kind of get away from, some of the things that I think the cluster API community has kind of relied on. Our users kind of rely on being able to manipulate machine sets and machine deployments and whatnot. But
I mean, you can imagine not doing it that way.
right.
It's just sort of superfluous wrapping. You have a whole bunch of machine deployments with a replica count of 1.
Right.
That's possible, but it seems
like
wrong.
Yeah, I agree. Like, that's the way I've been thinking about it in my mind initially. When I initially thought about what it would mean to have a cluster API provider for Karpenter, that's kind of what I was thinking. Was it like a user would have like 50 machine deployments and everyone is a different spec, and then those all get aggregated and sent back to Karpenter like, hey, here are all the machine types I can make, right? But that's going to be a horrible user experience having to manage like, a machine deployment for every different configuration, right? So maybe if there were a way for the individual providers to give that information back without needing to create machine deployments for each one, and the community is okay with kind of having this topology where you have machines that don't have an owner, right? They don't have like a machine set or machine deployment. That might be a way forward for us, right? Because then we could build an interface where Karpenter could talk almost directly to the CAPI providers so that they could give that information back. Please, Jonathan.
So I'm just trying to understand, like, again, forgive my ignorance on like all the details of CAPI. I'm still getting a little bit more familiar with them, but trying to understand like what we're thinking about as the integration point here. Like, is the idea that we would create a node, like Karpenter would make a decision on a node claim, and that node claim would then spawn like CAPI CRD constructs under the hood down to make like machines and machine point. Like, I'm trying to understand if that makes sense, because Karpenter already has all the like the nuts and bolts details of how to, at least within the current cloud providers that are supported by it, like it has the nuts and bolts details of how to spin up and spin down machine, or I guess we call them node claims, but like spin up and spin down like those instances wherever, whether they're in right now, whether they're in Azure or AWS. So I guess I'm curious, like, is the goal here so we can like expand out the set of cloud providers that are supported so that like we can orchestrate that, like use that node claim and kind of use Karpenter as like a scheduling simulation mechanism and not handle the provisioning piece and let CAPI handle the provisioning piece? Or are we going to leverage the provisioning piece with Karpenter and somehow let, like, I think this is the question maybe that Ellis was trying to pose last time, like let CAPI and Karpenter live alongside each other and have CAPI orchestrate like the cluster creation and then hand off the like underlying infrastructure creation down to Karpenter.
So I think, like, Jonathan, I think that's like, the $100 million question, right? Like, because like in my mind, when I first started thinking about this, I kind of envisioned it in two different ways, right? And like one way would be like just a generic CAPI interface, right? And so like, what if Karpenter could just talk to the CAPI objects, right? And if that were the case, that would open up a whole new range of providers who could, be utilized, because they could, using the common CAPI interface, if Karpenter were able to talk to that, then we could open up all sorts of providers. But I think as the details are coming out more and more, it's sounding like that may not be the best way to do this. And so now what I'm thinking about is, at least what I'm researching is kind of this hybrid approach where, like, could we create, and basically to answer the question you were asking, like what I'm looking at now is like Karpenter does the scheduling and whatnot. The actual provisioning would happen by the CAPI provider, so that in a way we can still use kind of the best parts of Karpenter for doing the, all the scheduling and kind of provisioning requests that we want. But then we could keep the logic that the providers have already been working on for doing the creation of, instances and whatnot. That could kind of stay similar to where they're using it in CAPI now. Now, I don't know if it's possible to do this or not, but that's kind of what I'm thinking at the moment. Jonathan, please respond.
Yeah.
Jack can wait.
Yeah, I'm a little bit like I wonder if we can converge these things over time, because I'm a little bit and I know that there's like a lot of existing customers that exist on Cappy today, so it becomes kind of difficult to merge these constructs, but it obviously sounds a bit redundant to me to like just use, or not redundant, but like just use Carpenter as a scheduler and then not use the provisioning piece, which some customers are going to use for like, some people are going to purely use Carpenter and then use like leverage all the provisioning behavior and have all that. And so we've implemented some cloud providers that allow the provisioning behavior. And then for Cappy specific users, we're going to like create a node claim and not react to it in any way. Like the Cappy cloud provider mechanism is not going to react to the creation of that node claim in any way, but it's going to then like react to it in the sense that it'll then create a machine, which under the hood will create, or whatever the mechanism is under the hood, like create the machine, which will reconcile, which will cause the infrastructure provider to like actually create the underlying instance and not really like have Carpenter do that per se. I guess it's a little bit, that piece is ambiguous to me. Like we're creating additional custom resources under the hood so that we can create an integration point, but we didn't really need to create those custom resources to begin with. I guess like we could have just created the single resource and then reacted to that resource. But just because the way that the providers are built today, like we are having to create these additional layers. And I wonder if over time those layers collapse.
I mean, great question. I don't have an answer, but that's a great question. Jack, I don't know, please.
Yeah, so I wanted to chat a little bit about Jonathan's suggestion that Cappy and Carpenter kind of live side by side, and Cappy creates the cluster, and then Carpenter does the Carpenter things. As far as I can tell, you could do that now. Is anybody doing that now? Does anybody want to admit that they're doing
You
that now?
can do that right now. You have to
Okay.
use an EKS cluster for that to work, but you can do that.
Why does the EKS requirement?
Because Carpenter assumes that it's going to use the EKS bootstrapping to join the nodes of the cluster, and that's the only way that's going to succeed. It's not going to work with like a kube ADM cluster.
Well, I think the point I'm making is that I mean it's gonna be hacky, but the point I'm making is that you can have nodes join a cluster created by Cluster API, and Cluster API doesn't know about these nodes. That this sort of hybrid operational environment seems totally possible today. So the reason I'm bringing this up is to just maybe see if we can agree as a community that that's not what we want. Like, because wouldn't even be, to me, it wouldn't even be worth defining how to do that, because there's probably a few hacky ways you could do that. But I think we don't want that. We're literally trying to prevent folks from having to do that.
Yeah, could you just restate the kind of premise there again, Jay?
Yeah, well, the premise is that you could run Carpenter on your Kappa cluster by building a Kappa cluster and then getting to some sort of cluster creation goal state, like my cluster now exists. I've got a control plane. And now you just, as another process, installs the Carpenter runtime, puts in the necessary plumbing to communicate with the Cappy created control plane. And then now you can just start creating new nodes. Cappy doesn't know about these. Cappy just knows about Cappy, assuming that you created like a kind of empty cluster. So it's just like a control plane with no worker nodes at this point. That's all that Cappy knows about.
Yeah.
So Cappy would be able to scale out your control plane, but Carpenter is responsible for, your actual workloads that are going to be dynamically scaling in and out according to production traffic. As far as I can tell, you can do that today. So my understanding is that the reason this group exists is to figure out how we can do better than that. Or not better, but like just have this be easier and more integrated.
Just so I understand, Jack, so I'm trying to converge on like what is the gap here. The gap in my mind is, based on what you're saying, is that we want to run Carpenter on the management cluster and have it react to create instances as part of the clusters that are being orchestrated by the management cluster. Is that what we're trying to get to?
Yeah, actually, I think the same thing is actually in play, that is currently in play with Cluster API, with Cluster Autoscaler on Cappy. You can actually run your dynamic scaling runtime on either the management cluster or the workload cluster. You just need to set up privileged communication. Depending on where you run it, the privileged communication plumbing is going to be pointing in one direction or the other. So actually, there's going to be flexibility when it comes to that. In the situation I'm describing, I would say running it on the management cluster makes actually less sense because you're explicitly not using cluster API to create all these worker nodes. The only communication you need between potentially Karpenter and Cappy is how do I get the right secrets so that the nodes that I create as a Karpenter provisioner can join this existing cluster. So you're going to need, but you don't actually need to do. You could do that. You could have some totally orthogonal process to do that, but that's the only thing you're going to need to account for.
Right. I was just trying to get to. Oh, sorry.
Go ahead. No, go ahead.
I was trying to get to the goal state of where, because again, I have some gaps in where my Cappy knowledge, but is the goal state here is that what you're saying is that Karpenter can reason about like remote clusters, basically, like clusters that are like from the management cluster, it can orchestrate the instance creation on other clusters, or is it that like what's the goal state, or is that the Karpenter lives?
I think the goal state for this group, Mike, you should actually probably answer this, but I'm going to just.
I was letting
the
you
goal state
go.
my attempted description for the goal state of this group is from there's two vectors I'm thinking. From the user vector, the goal state is that my Karpenter enabled cluster API cluster is I can introspect and potentially even maintain everything in the cluster through the standard set of Cappy interfaces. So there's a Cappy equivalent abstraction for every node that's running on my cluster. So in Cappy, that's a machine. It's an Azure machine if you're an Azure, AWS machine. So I should be able to go on my management cluster, which is the cluster running all the Cappy foo. I should be able to get a shape and a view of my cluster using the standard Cappy interfaces like kubectl get machines, blah, 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 blah. I should have a Cappy equivalent of all the things that are running. So that's like for me, that's a user goal state, is that I've got Karpenter doing all my scaling out and in, but I'm still dialed into Cappy. Like I'm able to view my cluster through like a set of Cappy interfaces.
But those machines live on the management cluster, or they live on the worker cluster?
The worker cluster.
Oh, I see.
The thing that lives in the management cluster is the CRDs, is the Cappy representation of those things.
Right. So that's what I meant, is like the machine custom
it's
resource.
Just think of it like a portal or something, you know.
Yeah, but this is I'm trying to get an understanding of the implementation. Does the machine custom resource live on the management cluster, or does it live on the worker cluster? For the worker
cluster. The management cluster.
Okay, perfect.
Management cluster.
What I assumed. Okay.
So the worker cluster is, you could think of it as just it's just following orders. It doesn't even know that Cappy exists.
Right. Yeah. I have to
it's just a Kubernetes cluster.
We're at time and I have to drop in a minute, but I did want to respond to what, Jack and Jonathan, because I think like Jack, what you were talking about kind of brings back to what Jonathan was kind of originally getting into. And so like, I think that the goal of this feature group is exactly kind of what Jack was talking about there, is we would like to figure out a way where we can integrate Karpenter into cluster API clusters such that cluster API users can continue to have the experience that they're used to with the cluster API CRDs and manipulate the infrastructure of their cluster through those CRDs, but get the benefits of Karpenter. And so like, yeah, like if we, just promoting more Karpenter, like integrations with specific cloud providers is cool, but like if that's all we do, then like it still doesn't achieve the goals for the cluster API users who say like, I want to be able to see machine objects. I want to be able to create a new infrastructure machine template when I want to put a new instance type in the cluster. And so like, if we can figure out a way for the users to kind of use those and have it mesh with what Karpenter is doing, that would be like, in my mind, that would be like, we would really hit the mark well there. And I'm not sure what it's going to take to get there, but like, we're still learning.
Yeah, I know we're over. I just want to add one more thing. The other goal state that I'm thinking is we're trying to discover, is there a way to economize the creation of a ecosystem of Karpenter providers through Cappy by creating, let's say, if we're able to create within Cappy itself, a single common Karpenter interface that can then unlock the set of Cappy providers to very easily opt into Karpenter, then it might be easier to create 8 new carpenter providers much more quickly and more effectively and in a more standard way than it would be using the current like carpenter provider interface. So I don't know if that's actually possible. And I think Mike also doesn't know if it's possible. We're asking ourselves, is this even possible? But that would be a huge win, is if we could build something into CAPI that would allow Kappa and CapZ with a small amount of work to get all that carpenter stuff for free for their environment.
Yes, exactly.
That would be super powerful.
And I just want to say, I just want to note from the chat too, Mike had to drop, but he was kind of +1ing what you were saying, Jack, as a CAPI user, you know, that's kind of what he would expect as well.
Cool. Thanks for letting me barge in and talk so much, Mike.
No, hey, no barging at all. Like, happy to have you here, Jack. All right. I think I have to run to another meeting. Thank you everybody for the participation. We won't be meeting the week of Christmas, New Year's. So see you all in a month. Go do some research. I certainly will be. Hopefully we'll have a good discussion then. Thanks, everybody.